Hi and welcome to our documented blog of the conversion of our lead acid system on our 47-foot Oyster to a lithium iron phosphate system of similar size. We went with all Victron equipment because of quality, robustness of the equipment, the fact it talks to its neighbours and tells you what's going on, and the fact that it's marinized, so lots of the connection systems, bolts, etc. are all stainless, so no problems with corrosion, etc. Why did we change to lithium? Well, existing systems were on the way out. Some of the batteries were getting old, they were outgassing, setting off alarms on the boat. We also have a lot of 240 volt systems which we wanted to be able to run, so we were converting to a new cooker, an electric hob. We're also got a washing machine on board. We have a lot of video blogging equipment such as our iMac, so we needed the flexibility to be able to use that power, and realistically we wanted to be able to use all our battery power. So on a lead acid system you can only use 50% of the capacity, whereas with lithium batteries you can run them right down to 10%, so you get more of the power you're able to use. I did a lot of research before I began the project, read a lot of books. I am an engineer, so I was able to understand a lot of what was going on, but I had to go and refresh my knowledge of lots of electrical things, so that I knew what I was talking about and could understand what I was actually reading. I did elicit the help of a professional engineer as well, so I got them to check the drawings and they helped me with the commissioning the system as well. Did it remotely because we were under lockdown, so couldn't really call them in, and they were a long way down south in Ipswich. I think if to anybody who's starting out on this, I would say don't believe a lot of the hype you hear about it being a drop-in system. It's definitely not. It affects almost all the 12 volt systems you've got on your boat, and you will have to make some modifications to cabling probably, and rerouting things and rebuilding things to get it all to fit. Back on the boat, haven't videoed for quite a while. I'm busy doing some jobs today. Boat is in pretty much turned upside down, which is the norm on boat jobs. So today I'll show you what I'm up to. Floorboards are up. We've been doing a lot of design work, drawings and scale drawings of what we're going to do to change out this bank of domestic batteries and turn them into lithiums. So I've got some drawings. It's quite complicated to get the wiring and the bus bar system, the Lynx bus bar system in there. So a lot of squeezing and figuring out where wires go and things like that. Also did a lot of work on the internet looking at other people's circuits and how they worked. So in the box are one of the lithiums, the Victron 200 amp hour, much smaller than the existing batteries and weigh a lot less, so 200 amp hours in this, before of these, and we can use down to 10% of the battery capacity. Whereas the old lead acid batteries, you can only use them down to 50% before you start to do damage to them. Lots of other parts of the boat had to be modified, including the main bus bars and distribution switches. As part of that task, I've got to fit. This is the existing inverter charger, which is too small, so it's like 1500 watts. And what I need to do is to put in a larger one, which is 5000 watts. And in order to do that, it's bigger than this one, and it's fatter, so I can't put it in there. Basically, I would have to come up into this cupboard here, and it would just be too big. So decided to put it lying on its back in this cupboard here, so I'll lose some storage, but I'll gain some storage back there because I'll move the galvanic isolator, which is that black thing. I'll move that probably over that side, so I end up getting this bit of space, and this was being used for spares anyway, so I'll put some shelves in there and keep some spares in there. The problem I've got is underneath where I'm going to put the isolator is water tanks, and the lids for the water tank go under there, so I'm going to have to make this kind of obviously removable if I needed to clean the tanks out at some point. This area of the bilge is also going to be used for the control systems. A box of goodies here with lots of Victron stuff in it. We've got battery to battery converters, control panels, and we've got some links, distributor panels. So these are these things that well, I won't take those out of the bag. Lots of bits and pieces that have to fit in to the same space as we're taking out the old batteries and moving some wiring around in there. This is the old bus bars that's got to be replaced. Although I did a lot of the drawings initially, I got the engineer to check them, and he made suggestions, and then I revised them, and that kept going until the end of the job, so we had a record of what I'd actually done. So I'm on the boat today. I have been working on removing the batteries, so I can get some work done on the battery box itself, which is there. I've removed all the cables from the batteries, pulled them all back, marked them all, and I now need to unscrew this from its support, lift the last battery out, and then we're ready to lift the battery box out. So the battery box needs to be another 50mm longer to fit all the batteries I've got to put in there. So that's my next task. While I was doing all this work, of course, I needed power on the boat, and I used the old batteries to do that. So what have we got here in the corner? This is the Victron 5000 inverter charger that we're going to fit to the boat. This is what it looks like. It probably weighs 30 kilograms, so I wrestled it down the steps. This is the mounting plate for the inverter charger. As we said, we can't put it in here because it's too big to go in there, so putting it in this locker on this end. So there's a backing plate that goes in here which latches onto it, and behind it I've got a cement board. It's supposed to be protection in case it got too hot. I've taken the front plate off this, and I've just got a strap through it, and I'm going to move it into place over here. Once I've got it in, it has to be in there and then slid back, and it hangs on these hooks here. And then there is actually a pair of holes that stops it moving around. So that's the unit in position. I'll just undo the band that holds it in. There's plenty of space for air movement around it, and I'm thinking I might put a grill in here just to give extra airflow through it. There's space to get the cabling, the big cabling in through here, and I'm going to put a conduit down here and round to the batteries. I'll just leave this casing on here. It's supposed to be screwed in, but no doubt will be in and out of there. So time to fit the big terminals onto the end of the 120mm cabling. These are the biggest cables you can actually fit into the box. So I've finished the bilge painting. I cleaned it all out. I wiped it with mech fluid and then dried it with the vacuum cleaner blowing. So it was all dry when I did it, and I wiped everything down to get the grease out of there, so hopefully it's got a good grip on it. On the boat, had a bit of a bad cold after New Year, so I haven't been on the boat for a bit, just recovering, so I'm still a bit nasally. Apologies for that. But boat's in a bit of a state. Did do a bit of tidy up after I got the inverter charger fixed up and in position. I've got to figure out lengths of cable for the big cable to go around and into this area where it'll go into the linkses. I'll probably try and pull the battery box down and do another trial fit with that, so I can get the cable lengths that go from the battery bus bars over to the linkses, and then I'm going to have a look at what needs to be done in this area. So I've been working on the battery box. I've added a gap in here, 60mm between them, ground this surface down to a fine edge, both sides, remove the gel coat off the inside, and I've just got a couple of, or 3 battens screwed in here just to give me the gap, hold that in place. And what I'm going to do is to fill this with some ply with some tape on here to stop it sticking, and then I'll glass over this surface one side, and I'll remove the battens and then glass on the inside, and then gel coat it, and then put some bilge paint on the outside there. So this will be the battery box increased in size as required for the new batteries. Tried the battery box back in, put the brackets on the side here where the support goes for the links, so they go in here. And this is the new bus bar which we fitted the system. I did actually fit this incorrectly and managed to put it the wrong way around, so it caused some problems later in the build. We'll talk about that later in the lessons learnt. I also have to fit this control panel, and I'm trying to decide where I was going to put it, in one of the cupboards or on the control panel. I've decided the control panel is the place for it to go, so that would be around this side here, and it'll be going in this panel at the end there. But I need to get a surface mount box for it, so for the time being it's just going to have to live stand alone until I get the surface mount needed for it, and it'll also protect the circuitry at the back of it. So we'll be able to use it to run up the system, but I'll have to wait for a surface mount. Nice sunny day today, and then so some shed work, because I'm kind of stuck unless I do this. So I'm working on the kind of unit between the batteries and the rest of the systems. It's the links distributor system, and I've got to fit in here an isolator switch for the batteries basically, so that I can switch the batteries off if I ever had a problem I had to maintain it. These are the links units, so these are basically bus bars. The battery will come in here, and charging and other things will come in there, plus outlets to power everything on the boat. So we've got the shunt here, which basically manages and tells me what's going in and out of the battery. And then in here I need an isolator switch, which is going to be this. So it's the heaviest duty isolator I could find. The only problem is, as you can see, is the kind of level between where the connectors go in here and these bus bars here is different. So I've got to build something up to bring it up a little bit. And then I've also got to make sure that I can get in through the sides. Now, I don't understand why this unit's made with gaps in here for like a bus bar, and then in the sides. It seems a bit odd. Anyway, I'm going to have to come out this end, so I'm going to have to trim a little piece out of here to get a bus bar in here, put a bar across the top of here, and then I can feed the output from there. And as if by magic, I made up a couple of bits of plywood that I'll epoxy and paint up, and then the unit will go on here. It'll go in there somewhere, balance it up, and then I've got some bus bars to make up to go in here and in here. So that's the next part of the job. And these are the small bus bars I made up. This is the link system all built up. Okay, so I've been working on the battery box this week. There's quite a few extra bits that have to go in it, so I'll explain what's going on. So the engine batteries go up that end, and I've got a battery protect going in here, which will be above the engine batteries. So that will allow cables to go through the battery protect and then on to other circuits in the side of the control box where the fusing is. Back on the boat this morning. Had a few days when I've been working on this box, lengthening it. So I brought it back in just to trial fit it before I finish it off. Discovered a bit of a problem, because when I put the lid goes in under here, so it goes under there, and you have to lift it, slide it back, and then pull it out to get it out. I can manage to get it in, but the hole where the wing nut that holds the lid down was positioned previously is now under here. So I've got to just move that and put a new hole in and a new fitting on the box underneath. So this is the other area where I've got to do some work. The main cables that will come from the inverter will have to come across and go through the box here somewhere. So I've got to make a hole there for it. So I wanted to bring it, just see where I can get the cabling out of this tray, bring it across, probably have to support it on something, and then get it to go into the back end of the of the box, and then it'll run down the inside of the box here till it comes into the links distribution system, which is sitting in here. This is a fast forward of me installing the cables supports inside the battery box. These big cables need to be supported so they don't sag, chafe or overheat when they're inside the battery box. And this is a fast forward of me installing the links distribution board beside the battery box. I've got to fit a battery strap in here to go over these batteries, so I'm going to drill this down here and drill one into the floor, bolt this through and screw that one in there. The links bus bar system, the isolator, and then this is a shunt that measures power in and out of the battery. I've just tested the lids at the moment to make sure they went in because they were a bit tight to fit in place. So now I've got to fit these cables from the batteries. So there's the two positives that come from the positive bus bar, and there's two negatives also come from there, and they go to another bus bar that's along these and attach this end, so they come back and into there. And then I've got the remainder of the cables which basically come out of here and feed the power systems and the battery protects, and then there's also power that comes from there and goes off to the 12-volt domestic system. I've fitted a stainless bar that supports the cable conduit. I've also made the bases for the DC to DC converter, the Orion Smart. So there's two of these go on here, and then basically this board folds up, sits here, and there's a couple of blocks underneath it to support it in the bilge area. So this is the panel that's going to go under the floor. There's the two battery to battery converters, the Orions 30 amp. There's the VE bus BMS and the Servo GX. And then there's going to be some bus bars in here that I'm just about to fit in. So I'll put the bus bars in. The pieces are all on the board that goes under the floor in here. So it's going to go in there. And I'm just going to do a little bit of preliminary wiring before I put it down there so that it's a bit easier. I'll maybe just trial fit the board that I made up and make sure that fits in okay, and what cabling and ducting might be going on there. Bilge stringers don't allow it to go in square, so it looks a bit odd. There is a plastic cover going to go over this when it's finished. And lots of cable management to do once you finish these projects. Today's little task is to finish off the cabling in here. I pulled one of the big cables back from here, I had a bit extra in here, so I'm going to line that up, pull these cables up which have been hanging here for a while, and sort out the cables that go into the bilge. I've already put cable covers on them. Got one more cable to run from a high level bilge alarm, and then that should be finished. And all the work in the main distribution board and recabling that to be done. I rerouted a water pipe that I didn't want in amongst all the electrical cabling. And in addition to the work on the lithium system, I also had to swap out the original Volvo alternators for a new Balmar alternator. You see the alignment of the belt is roughly where it needs to be, but unfortunately the bracket doesn't quite fit in that alignment. The front part of the bracket probably looks okay, might need to be able to space that out, but the back end of the bracket where the tube is definitely doesn't fit properly, so I'll have to make some modifications to that. So this is the Volvo D260 that we put in last winter. It did have a Volvo alternator in here, and I've taken that out and I've had to modify this bracket to suit the Balmar. So I had to make up two new little brackets and a new piece of tube in here, so we fitted that. I also needed to, you can just see underneath here, there's a stabilising bracket which was the wrong alignment, so I've had to rebend that a little bit, and the tension is now on it. So what I've got to do is to fit this control external regulator, which is hooks into the Balmar, and it controls the output of the alternator depending on temperature and things like that. So it reviews the reviews temperature on the batteries and also the temperature of the alternator, so that you don't overheat it and overload it. That's the intention of it. And the other alternator had an internal regulator, more designed for cars and vehicles, so it's not really suitable for this type of task when you're charging large ampage. So this will churn out 170 amps, and we'll probably tune it down to take 130 to the batteries, and that'll be good enough to charge them quite quickly. So that's the objective. We basically fitted this to stop the old alternator frying itself when it sucks too much, because it would only produce 70 amps, so half what this will produce, and yeah, it could have ended up burning it out pretty quickly. So although I've been working on the battery box for the main bilge, there is actually another battery going in the boat. The project basically has all sorts of tendrils that run throughout the boat, and one of the things we're going to have to change is in the bow of the boat. We're going to put a battery up there, so I'm building a little battery support for that battery that will run the anchor winch and the thruster. So these are the bits for it, and it kind of goes together like that, and then the other one goes on the top of it. They'll be screwed down, so I've cut them out. I'm just epoxying them everything tonight, and then eventually they'll get a coat of grey paint once we assemble it all, make sure it all fits together. This is how it all fits together eventually. So there's two layers of plywood, one on top of the other, and then what you have is one of these will be permanently fitted, probably this one at the back here, and this will just lift off altogether, and you can pin it, so it'll have bolts through the corners and the other spots here, and then a couple of straps over the battery as well to hold it in place, and the whole thing will be screwed down in the forepeak. Working in the bow locker today. I've made several pieces in here. I'll show you what I've done. There's a baseboard in here which is glassed in and screwed in. There's a tray, which is this grey thing, for the battery itself. I've got the battery in there, just starting to hook up the lines to it. I have a load of straps that strap it down into the tray, and then in this area here I'm going to have a switch, isolation switch, fuse, and I'm also going to put a shunt in here so I know what charge is in the battery. Yeah, so that's what we're doing at the moment. The controls up here are for the bow windlass, and then the cabling will also connect to the bow thruster. So main cables come through and go to the battery, and then come off there and split between the thruster and the bow anchor winch. Update on the bow battery. The battery is now in place. You can see it just under there. I've got it hooked up to the bow thruster. I'm still waiting to connect the charge circuits here, and there's another one down here. I've got to pull some cable, get a little bit of slack in it. The isolator switch is done, the shunt's in, the fuse is in. I've hooked up most of the cables and relabeled and reattached the solenoid box and the feeds for the windlass, and I've tied up most of the cables as well. I've got the straps on. They're all holding the battery nicely in the tray, which is under here, this tray here. So yeah, I'm ready to test it. I'm not going to run it with the charger on it at the moment. I'm just going to test the thruster and the windlass. Just fitted these are the monitoring cables for the batteries, so they go from the batteries to the battery management system and check whether all the cells are charging equally and the right temperature, not overcharged. So that's that control system there that monitors the battery. So we'll get the power up. So I've been charging the batteries with this Victron blue smart charger. I'm now charging the temporary lead acid batteries with it, but I charged each individual cell, well, each individual battery, and each one has a number of cells in it. I think it's 4 cells in them, so that everything was balanced when I hook it up. So I'm going to leave it like this to balance itself out. It should do that overnight before I'm able to power it on. I've still got work to go on in the fuse box area, and then I've got the work on the inverter charger, the main cables to the distribution. I've been working on the battery box and connecting everything up. So I've now connected the main bus bars here, and I've got little plastic caps on them at the moment. I've got some plastic washers to go underneath those as well, and I need to do something with the end bars themselves. I've also connected them into the links, so they're in there and fused. So everything's connected up to the isolator. I've also connected the main engine battery, which is that one, and this is the generator battery. So they're all in there, and I've also got the battery protects in here and wired up. And the small wiring that you see there is the control for the charge disconnect and the charge disconnect and the power for the battery connects. And behold the glory of the battery box. This is it, more or less finished. There's a couple of generator cables to come in which are not run yet, but everything is in, torqued up, bus bars on. I haven't switched it on yet, but there's definitely power there because I charged all the batteries up last night, or the final one was charged up overnight last night. But yeah, looking really good. Pleased with that. Exciting day today. I've managed to get the Victron batteries up and running, the lithiums, and the inverter charger. Had some help from the engineer. I used Oliver from Sea-Power Marine in Ipswich to review and suggest modifications to all the circuits and equipment that I used, and he also coached me through the commissioning of the system via a 3-hour FaceTime call. So thanks, Ollie, and I highly recommend Sea-Power Marine for their help. This is Victron Connect. Basically it's a list of all the equipment that you have on the boat. It's even picking up next door's battery monitor, but these are the bits of equipment that are in the system, and it allows you to go into each one of these and configure it and see what's happening. So on startup there's just blue lights flashing, no smoke, no fire, no sparks. Very pleased with the system, worked very well. We've got the monitoring system up and running, and this shows you what power is coming in and out of various systems. Just to prove it all worked, we cooked a meal on our induction hob system. Checked that none of the flashing lights went out or anything blew up. There you have it, the conversion of a circa 2002 800 amp hour lead acid system to a state-of-the-art 2022 Victron lithium system. Took a lot of time to pre-build and modify the existing structure of the boat and systems that were in there before I even began installing any of the new lithium systems. Are we pleased with the system? Yes, very pleased with the system. It went together beautifully, it worked first time, there was no smoke, no sparks, no fire, so happy with that, and thanks to Oliver who helped us out with the commissioning as well, because that certainly gave me a bit of confidence in what I'd put together. Any problems? Well, other than the ones I've mentioned, we didn't really have any problems with the installation. I did install the main battery shunt the wrong way around, and it's easy to do, believe me. It is marked up on it, but once you get the thing positioned, I couldn't actually see the labelling that was on it, so that's my excuse. But it gave us very confusing readings initially, and I couldn't understand what was going on, but once it was turned around, it worked fine from there. I think living with a system is probably also something that we've learned to look at battery condition. I'm able to keep the batteries topped up really easily. Monitoring them is great because we can go online with the Victron Connect and you can see what's happening with all the batteries at any time. Even if you're not on the boat, you can link it into the Wi-Fi system, and you can see what's happening on the boat from home. Hope you enjoyed the video. Probably the whole duration of the project took about 4 months, and I would say there's probably overlapped with that. There's probably about 2 months worth of drawings and research and ordering of parts and things like that. So it's not a short process. It wasn't for me. I'm sure you could have got professionals to come in and do it for you, but that was an expensive. That was an expense we didn't intend to take up. The other advantage of installing all this kit is that I now know what's there. I know how to look at the system. I know how it works, and I can also track down any faults when they occur. And I've got contacts with people that I can now ring if I have something that I'm not sure about, to check out what's going on. So these are now gone, and this spiffy system is now in place. If you enjoyed the blog, check out more YouTube tech vids and our sailing blog on Sailing to the Sunset.